So this is the example that we're going to work with for a little while. We're focusing now. Yesterday we spent a decent amount of time identifying the initial value and the rate of change. The reason we start with that is because now when we're comparing functions, we're going to make some generalizations about those rates of change and initial values. Maybe one is bigger than the other in the beginning. Maybe one grows faster than the other. And you'll see situations like this. So we have a biologist who studied the growth of two different trees over a 5-year period. At the beginning of the study, she measured the tree's diameter. What's the diameter represent? If I'm thinking about like the trunk of a tree, yeah, it's actually the measurement straight across. It kind of that represents like how thick the tree is. As trees get bigger, they get like wider. The biologist took the same measurement every year to determine the growth. We had 2 trees, and this is a very common way that you'll see functions compared. You have the red maple, which is given to you in just a sentence. The red maple in the study had a starting diameter of 4 inches, and the diameter grew at a rate of 0.3 inches per year. So that's the red maple. And then the silver maple is given to us in the graph. So we're going to compare these. We're going to identify which one had a greater initial value, which one had a greater rate of change. You won't always see them in the same format, but we might want to manipulate a little bit to get them into the same format. So let's take this table here, which a lot of us like working with tables because you're very comfortable, especially coming from 7th grade, working with tables. So at the beginning of the study in year 0, the diameter of the red maple is 4 inches, and then it grows 0.3 inches per year. Who can help me fill in this table for the red maple? What values can I put in the diameter spaces?
For 1, you can put 0.3.
For 1? Do I want to put that for 1?
No.
Why?
Because there's still 4 inches.
What do you mean there's 4 inches?
It's going to be 4.3.
It would be 4.3 because at year 0 there's still 4 inches.
It has to be here 4.3 because at year 0, what do we know about the tree? It was 4 inches at the beginning. Imagine if you buy a tree, you're not necessarily just buying a pile of dirt. You might be buying like a little baby tree. So it was 4 inches in diameter at the beginning. And then after the first year, 4.3. What about after the second year? 4.6. What about the third year?
4.9.
4.9. How about the fourth year?
5.2.
And then the fifth year?
5.5.
5.5. Good. So this represents a lot. We have a lot of information here. We can actually write an equation based on this situation. We'll get to that in just a second. Can I graph this? If I wanted to graph all of these years, what would this graph look like? Where would my first coordinate be, or my initial value? 0 and 4. I want to represent that in year 0, this tree was 4 inches in diameter. And then how would I plot the next point? When x is 1, what was the y value? 4.3. And then when x is 2? 4.6. X is 3? 4.9. So it's going to look something like that. Okay. Will it continue to grow? Yeah, there's really nothing indicating that it's going to stop growing. So we can show that rate as constant for now. So this problem is about the growth rate of trees. What other kind of rates have you worked with before? Think about rates.
Job.
What do you mean jobs?
Like, you get paid to do it, like to show up.
Okay, so if you're getting paid to work a certain amount of money, or maybe $10 an hour, that would be a rate. What else is a rate?
Cupcakes per minute.
Eating cupcakes per minute? Or making cupcakes per minute? Either way, right? If I'm a baker or if I'm just someone who's hungry. Food is a big one. What else?
When we talk about speed,
Speed, absolutely. Absolutely, speed, yeah. If your car's driving certain miles per hour. Absolutely. Can we compare any 2 rates? Yeah, I mean, I could. So look at this example. If this was company A and company B, who would you rather work for?
Company.
Company B?
A.
Why A?
Because A is paying you for minutes.
So I heard some people say company B. If you answered company B when you first looked at this example, why did you say B? Because it's a 6 and a 5. So we would think at first glance that 6 would be better than 5. But what's the difference?
1 is per minute.
1 is per minute. Company A is per minute. and the other company is per hour. What do I have to do before? Now, a lot of you looked at this, you're like, wait, $5 a minute, you're gonna end up making more than $6 an hour. But what do I have to do to one or both of these so that I can compare, as we say, apples to apples instead of apples to oranges? Meaning, I have to compare things in a similar fashion instead of like comparing two totally different things. Jordan.
So multiply the 5 by 60 to get 60 minutes, which is an hour.
I can figure out $5 per minute is how much per hour, which is how much?
300.
Dang.
Oh, wow.
Can I get this job?
If you saw it like that, would it have taken you long to figure out where you would prefer to work?
No.
No, but the units matter. The units do matter as we're looking through examples like this. Okay, so now let's go back to the silver maple and go back to the red maple. Let's talk about the initial values and the rates of change. What ordered pair represents my initial value on both of these graphs? For the silver maple, what's the initial value? What ordered pair?
0.
Where x is
0.
0
Oh yeah, 3.
and y is 3. Good. How about this one?
0, 4.
X is 0, y is 4. What do the initial values mean in context for the silver and the red maple?
Diameter
Is it the diameter growth? My initial value represents what in the context of this problem?
How many inches they were to begin?
At the beginning of the study, how big were they? The silver maple was 3 inches in diameter, and the red maple was 4 inches in diameter. So which one was bigger? The red maple, and it was 1 inch larger in diameter. Absolutely. So now, which way do the lines slant? How are they moving? They're going up, which means what's happening to these trees? They're increasing, meaning the size of them is, it's getting larger. Yeah, the trees are growing. The trees are growing. And we want to focus on the positive change because eventually the signs will matter. All right, tomorrow we're going to talk about some negative change. Okay, so for my red maple, how can I represent my change in y compared to my change in x? If you remember, we did the table. How much was my red maple growing every year? Every 1 year, what was happening to the red maple when we filled in the table?
0.3.
It was growing by 0.3. So that means every year that passed, it grew by about a third, from 4 to 4.3 to 4.6. If you're group 2 on iReady, please head over there now. How about the silver maple? What is my rate of change for every 1 year that passes? How much bigger is my silver maple getting? How much? Take a look at the silver maple's graph. How much bigger is it getting every year? Hold on. Look at the units on the graph. Think about this. Quiet down, please.
Please pardon the interruption. Elizandi Beth Velasquez, Jacqueline Velasquez, please report to the main office with your belongings. Elizandi Beth and Jacqueline Velasquez, please report to the main office with your belongings.
If I need to figure out the growth, I need a couple of pieces of information. I know at the beginning that the tree was 3 inches in diameter. What other measurement do I know for certain? I know that in year 2, my tree was 4 inches in diameter. So what happened?
It goes up by 1.
It went up 1 inch. So it grew an inch. In how long? In 2 years. So how much did it grow in 1 year? Half an inch. 0.5. So what do these rates of change represent in terms of the problem? We have the 0.3 and the 0.5. How many inches they're growing every year? Which one's larger? Which one's growing faster, I should say?
Silver maple.
The silver. The silver's growing at a faster rate because its rate of change is larger. And what do you notice about the line of the silver maple? It's steeper. It's moving, it's going up faster. That is what we would consider steep. And if I had to put these on the same graph, it would look something like this. And over time, like yes, the silver maple's starting smaller, but because it's growing faster, eventually it's going to surpass the red maple in its growth. We already answered that. We are going to do this problem for about 3 minutes because you're going to work with the people that you're sitting near. If a table and graph are provided to show how much money a store earns selling a team's t-shirt, which is represented in the table, and a team's cap, which is represented in the graph, how would you find the initial value and the rate of change for each? Because once we find them, we want to compare them. We want to know which function there has a greater initial value, which function has a greater rate of change. Let's take 3 minutes. I'm going to pause this as you work. But let's take 3 minutes and find the values that represent these functions.